Welcome back, everybody. This is going to be part 2 of the practical 3D design using FreeCAD. As you remember last time, I just did a quick video for this flashlight here, and all we did was create a jacket or shell for the 18650 cell so that it would fit in this flashlight and not rattle around. So what we're going to continue to do today is talk about and design a case that we can recharge those 18650 cells in. So as I mentioned in the first video, I can get these rechargeable batteries from the dollar store. As you can see here, they are $4. It's 1800 milliamp hours. And that's what we use to get our 18650 cells from. And what we're going to end up doing is building something like this. This is just a first revision with some errors. So we're going to start from scratch and basically redesign this. The idea is that we can open it up and put an 18650 cell in there to recharge. And we're going to use the electronics and everything from this cell. So first what I'm going to do is go over to my desktop and we will start up our FreeCAD so that we have a place that we can put in our numbers and things, and at the same time we're going to go and we're going to open this. So there's a little power bank. You can see it has a USB-A and a USB, micro USB output. And this is the way you take power out, this is the way you put power in. It does come with its own little cables and things, but we're not going to use those for this. And you can see here there's the mold lines where the two shell halves go together. So let's just take this apart so you can see what you get inside. Quite easy to take apart. And inside you can see there's some charging circuitry, some wires, and an 18650 cell. And there's a little bit of this goop here to glue it in so it doesn't rattle around, but that's easily taken out. And there we go. And we don't need these pieces anymore. So there is our 18650 cell. Take that goop off. So that's just going to interfere with us later. Careful not to breach the cell. Alright, so we have an 18650 cell, some wires. You can see it's got a tab soldered on each end, one there, and one there for the wires to go on, and this little charging board. So what we want to do is we basically want to take this charging board and add it into a spot like that at the top. And then we need to have some way of contacting the ends of the cell. So what I'm thinking of is probably a folded piece of metal. Here's a concept of a folded piece of metal. And that will fit down in this slot here and reach out here. And also one will be in here and reach out. So that when I put the cell in, they will contact the ends. And then we'll design it so that you can close this up. The cell will be secure inside, and you can plug it into a charger. Basically, it'll be the same thing as this power bank, except that we can take the cell in and out. And if you look at the sizes here, you can see that our case that we're making is only longer than this by the ends where we're going to put our pieces of metal for recharging. And other dimensions are pretty much the same. Right? Pretty much the same, except for the hinge that's going to stick out here. Okay? So a little word about hinges. In order to have a hinge that opens up all the way, your axis of rotation of the hinge has to be outside of the edge of the box. So for it to come out here, to the edge of where our box is, you have to have the hinge rotation outside of the box. Otherwise, it'll bind up on its own self and only open up 90 degrees. Now we could build it to open up 90 degrees like that, but I thought it might be a little harder to get cells in and out, so we're going to design it to open up 180 degrees. You also may notice that it's this hinge is very tight, right? There's no seams there. This is very thick and robust, so you're not going to be able to put this together and print it in two pieces. This is actually designed to print in place. And you can see there that it was printed open, and there was just a little bit of touching there. Print in place like that, and then open it up, and it works. So this is going to be a print in place moving hinge designed to fit the 18650 and that circuit board plus the two pieces of metal we need. So let's go over to FreeCAD, and we'll see here we have it open, and we're going to go down first down to the spreadsheet and create a new spreadsheet. Oh wait, we need to create a new document. Let's create a new document first. There's our new document. Now we can create our spreadsheet, and then we're going to go down to part design because that's where we're going to work later. Okay, so we're going to leave that like that. We're going to go into the spreadsheet. So, like we said before, the two default values that I use all the time are based on my printer and the materials that I use and how I print things. One is what I call material thickness. This is a wall thickness, or number, or like the thickness of plastic, which I've used here. You can see here. That's this thickness here, which is very robust. You can see this is pretty strong, right? It doesn't flex or anything else. I find that if you don't print it thick enough and it flexes, the layers tend to delaminate. Even if you print it nice and hot, they tend to delaminate. But with mine, if I print at this thickness, it seems to be very robust, very strong, and doesn't flex. And for my printer, that is 2.4 millimeters. So then we'll add that in, and we'll give it an alias of material thickness. No spaces. I like to use the capitals at the start of the words. Enter. Now you can see this has turned kind of light yellow. That means that that value is set. The other one is, because we're doing print in place, there's a gap distance you need between parts so that they don't fuse strongly. Now, to make a nice tight hinge like that, you want that distance to be as small as possible, yet still be able to break open. I call that my standard gap. And for my printer, with testing, it was found to be 0.2 millimeters. So we'll give that an alias as well. Standard gap. Okay. So now we need some dimensions. Now, the first dimension is the diameter of our 18650 cell. Now, for those of you who don't know, 18650 is actually the dimensions of the cell. So it's supposed to be 18 millimeters in diameter. So we're going to put a cell diameter. Now, the 18650 cell is supposed to be 18 millimeters in diameter, but that's very tight. Depending on how tight your printer prints, and also if the cell has any swelling, any extra paint, anything else, it may not be exactly 18. So to give us a little wiggle room, we're going to actually make our cell diameter 19 millimeters. Cell diameter. And then the length is 650 millimeters. Or sorry, 65.0 millimeters. That's the 650. So the length is 65 millimeters, but again, we want to leave a little room for the cell, for wiggle room and things. And plus, we're going to have those little tabs that are going to be sticking out. So we're going to do a cell length, and instead of making it 65 millimeters, we're going to give it 2 millimeters on either side of the cell. That would make it 69 millimeters. So we'll put 69 millimeters in there and make that the cell length. Alright, so that gives us those. Now, so the only other thing we need to worry about is that little circuit board. Now, that little circuit board is designed to fit in the space of the cell, so it's already going to fit because of the width we're using. But what we need now is the length of it, so that we have enough space for it to fit in. So I'm going to grab our little calipers, our digital calipers, make sure it's on 0, and we'll measure the length of this board. So right now, This board is 21.5 or so. 22. Okay, but as you can see, the cables come off the end, and depending on how we put that in the case, we may need some extra room. So we can also give ourselves a little bit of wiggle room there. So with it sitting at 22.16, why don't we make that say 24? Even if that wiggles a little bit in there, we'll be okay. So we're going to come over to FreeCAD again and say board length of 24 millimeters. That's the board length. Alright, so the only other things we need to think about now is how we're going to put power into this cell. There are two things, right? We don't really care about getting power out, so, but we do need to leave space for that. But we need to get power in. Now, if we put our plastic right up to the end here, and just make a hole big enough for just the end of the cable, it's never going to connect, because we're going to have it sitting back this way, 2.4 millimeters. So what we need to do is make sure we have a big enough opening here. And I'm not really caring about like waterproofing or anything else, so I'm actually going to make the hole a lot bigger than we need. So right now, on this side, it's about 4 millimeters high, and it's 7.5 wide. But I also need one for the USB-A. And look at that one, and it's 13.25, so I say call it 14. So we make an opening that's 14 wide all the way down. That should work. So we'll go back to FreeCAD and go USB width 14 millimeters, and then we need the height. Now you notice that the board has one above and one below, and when we design our charger, you can see here it's designed to kind of sit in the middle. So if we make ours sit in the middle, so the board height is there, that should give us enough room for the top part. So if we measure this top part from the top of the USB to the board, it's about 8.5 millimeters. We'll go down 8.5 up. So we'll go USB-A height 8.5 millimeters. And that's going to be open all the way to there, but now we need some extra space on the bottom for this. So this one is 4, so let's make it, make sure this is zeroed. If I measure from the top of the board to the bottom there, it's 3.3. So if we make that, say, 4.5, that should give us room for a connector. So we're going to put it in here, USB, and we're just going to call it B just because it's the second one, and we'll make that 4 millimeters. So let's put our aliases in, USB width, USB-A height, and USB-B height. Alright, so there we go. Now we have all our measurements. Now we can go back into our drawing here and we can start our part design. So you can see when we're going to start our design, we're going to need to create a body to start. So now we have a body, and let's rename that body to the bottom. Alright, and you can see it's highlighted, so this is our active document. Now we're going to create a sketch. We have our 3 planes, top, front, and right. Because of the way we're going to print this, I'm going to use the front plane. And hit start. Okay, so there we are. So the important thing here is we're trying to do a print in place design. And we're not going to use an assembly. We're actually going to just do 2 drawings in FreeCAD. And the easiest point that I want to work from so that I can relate the 2 pieces is because this is going to rotate around a hinge. The most common point between those 2 drawings is going to be the hinge center itself. So we're going to use this center point here as the center of our hinge. So to create this shape for our drawing, we're going to start by using an arc. And we're going to use the center point of the hinge. And this is the edge of the outside edge of the hinge. We're going to put the box over on this side. We're going to use this as the outside edge of the hinge. But because, as you notice here, only the spot for the cell is down, we're actually going to draw the whole outside like this. So I've actually drawn this little curve right here. Okay? Now, in order to get a nice robust hinge, I found to use the center pin of the hinge has to be at least 2 times my material thickness. And then in order to get the outside edge of it strong enough, the piece that goes around that edge, I add another material thickness. So that's going to mean from here to the outside is going to be 3 times the material thickness. So I'm going to set my radius to that. So we go into set radius and hit the formula, and we're going to go to Spreadsheet, material thickness times 3. Okay, so this is now the edge of our hinge. Okay, now we need a line going up to the top of the box and a line going down to the bottom of the box. And then we need some nice rounded corners. Now we could use fillets later, but fillets sometimes add extra troubles. So we're just going to use another arc, one here and one here. And those are our nice rounded corners. And we need a top of the box and a bottom of the box. Oh, and you can see that these 2 did not meet up, so we're going to make sure that we connect that. Again, we're going to do our own manual filleting. One here, and then a line to connect them. There we go. So there's the basic outline of our box. But now we need to do some figuring of what we need for heights and things. So this one, and this one, and this one, and this one. These 4 corners, we're going to make them all the same with the equals up here. And now the radius of them, because we're using a material thickness, we're going to actually want to radius it to the same thing. So we'll pick this one up here, and we're going to set its radius to the material thickness again. Okay, now if we change our material thickness, all of our corners will look nice still. Okay. Now here, this left side, we're going to use our vertical and horizontal constraints like this, so that we have a nice 90-degree corner. And we're going to do the same down here on this one. Nice vertical and horizontal. Now for this corner down here, this side here we can do a vertical, but we can't align this one yet. And we'll do the same up here. Make this one a vertical. So there, if we look at this nice edge on, we have a nice drawing this way. Okay? Now you'll notice that this is not quite centered, right? The top is higher than the bottom. One easy way to fix this is we'll take out this vertical constraint, and we're going to grab this one, and then the line, and we'll hit center. Now we're centered. Okay? Now let's start adding some dimensions. In order to fit the 18650 cell in this box, the space between the outer walls has to be the diameter of the cell. So we'll go in here and hit this to Spreadsheet, cell diameter. Alright, so now an 18650 cell will fit in here, and then we still, because this is the radius is material thickness, we have material thickness up here and material thickness down here. So that fits our cell inside there. We're going to do the same thing down here. We're going to grab that point and this point, and we'll set it's the same. Alright, so now we have our 18650 cell. It should fit in there. Oh, you know what? I made that material thickness without thinking. We have to make this the cell diameter. There we go. Now you can see that this has moved all over the place crazily. That's fine. And these here did not move together, so let's take this one and make them the same. Alright, so now we have our main box here. We don't have our hinge and we don't have an offset. Let's make these look a little nicer. If I take this line and this line and say that use this constraint here, the tangent, we'll get a little constraint substitution, and now you'll see that this, when it comes along, echoes this curve. So this is a tangent now to this circle. We're going to do the same with this one. Make it tangent, and we'll do the same here. Make this one and this one tangent, and this one and this one tangent. Okay, so now we have a nice hinge design, and they move the way we want them to. But remember we said we need our hinge axis point to be outside of our box. So the only way we can do that is by setting the distance from this inside point, because these points here can move, from this inside point to the hinge point has to be the same as the material thickness. So I set this and this to Spreadsheet material thickness. There we go. Now our hinge center is just outside the wall. It's actually touching it right on the edge, which is like perfection for how it's going to work. We'll have to take care of making sure that we don't have any interference by using our standard gap with the lid. But you'll see why I put it this way shortly. Okay, I think I did this wrong here. I think this should actually be diameter. Yeah, let's change this. Let's make this the diameter, because that looks really large. Spreadsheet dot material thickness times 3. Yeah, that looks much better. That looks closer to what we have here in this design. Because we had 14 millimeters, and that didn't look right for that size. This here looks closer. Yeah. Much better. Alright, so there's our fully constrained sketch. So how are we going to make it long enough to fit everything we need? So we're going to use the pad. We're going to change it to 2 dimensions. And the reason we're doing 2 dimensions is because the 1860 cell here, you see, is not centered. But our second drawing, we want to be able to easily center this in here so that they line up. So in order to get the right dimensions, we're going to start from the center here, and one dimension is going to be this way, so you're going to have half the cell length plus the material thickness plus a gap area here plus the material thickness again. Okay, so how wide do we need this to be? Well, let's just decide on one. We'll come back to that pad. Let's go into our spreadsheet, and we're going to make our something called a tab length. That's just going to be the length of space we leave for our metal tab. And since we're making it ourselves, we can make it whatever we want. In this particular model, I made it 8 millimeters. So let's just go with that. Because I haven't made any tabs, we don't know how it's going to work out. But we'll make that 8 millimeters, and we'll give that an alias of tab length. Alright, now we can go back into our drawing and into our pad. So one dimension is going to be our cell length divided by 2 plus our tab length. So that gives us half the cell in the inside space, and then we need the material thickness times 2. So that gives us the one side. Now on the other side, we want the cell length divided by 2 plus the tab length plus the board length so we have the board length, the tab length, and half the cell, but we have 1, 2, 3 the material distance. So we're going to use spreadsheet material thickness times 3. And there is our basic cell case. Alright, so now we have a solid object that will not fit anything in it. It's just a solid tube of plastic. So now we need to add in openings for the different things, for the cell and everything else. So we can go over here to the left side and create a new sketch. Okay, and I don't know why FreeCAD does this. Rotates things, just does it. I don't understand why. But because it has done it, we're going to work with that. Go back in here to their sketch. So you can see we're looking at the left side, and we can tell by the letters that this is the top over here, and this is the center of an 18650 cell. So what we want to do is we want to take out a square and a little thumb hole here. So we can draw a nice line like that, and we're going to come in to touch the center line because that's also the center cell that way. This is going to be a problem. See, if I make these horizontal, then FreeCAD has a problem with redundant constraints. So some of these we're going to make a little crooked, and that's okay. Alright, so now I can take this and that and say a touch. Take this and that and say a touch. And make this one horizontal. And this one is not vertical, but at the same time we also want it centered. So because it's not horizontal, we're not going to have any problems. We can click there, and center it. Then if I make these equal, then this becomes centered. Okay, so now we have 5 degrees of freedom. So for this hole here, what we're going to do is that's so we can reach down around the cell. So right now the box is set up so that the cell is centered in it, and you can't reach and put your finger underneath of it. So we're going to make the height of this thumb hole, so we can reach under the cell, 1/4 of the cell diameter. So if we go spreadsheet.cell diameter /4, that'll give us a hole that's big enough this way. And just playing with the same things to make it easy. Why don't we make the width of this thumb hole the cell diameter, since we already have it here. That gets us that. So we need this opening to be the same as the cell length. All right. We have 2 degrees of freedom. Why do we have 2 degrees of freedom? What's not set up here? Ah, this one here is not horizontal. There we go. 1 degree of freedom, which is this length here. And because it's going from the center out to the edge, we know it's going to be half the cell diameter. So put that in here. Oh, I forgot to hit divide by 2. You notice that this is now inside, right? Because we forgot there's also material thickness. So we come back into our calculation and add material thickness. There we go. Now we have our material thickness. We'll pull our dimensions out just so they're easier to see. Fully constrained, hit close. Now we're going to use the pocket, and we can just simply go through all. Now, do you see a problem? If we go through all, I end up with this slot in here, which is not what I want. Okay, so we can change that back to a dimension. And in order to get everything to fit, we need this to be the cell diameter plus the material thickness. So we get material thickness on the front, and we're only going to go as far as the inside of the container. And we've left this spot in the back now. Okay. Actually, you know what? Let's redo that. Let's go back into our sketch, and we're going to delete these. And we're going to delete that constraint, and we're going to take this guy and this guy and make them the same. And we'll take that horizontal constraint off, and we'll say this one, this one, this one, and center. There. That works better. Alright, so now we've got our sketch there for the cell opening. We'll make a pocket, and we'll make it through all. Okay, so there is our opening for the cell that way. Now we need a spot to put the circuit board in. We also want to be able to put a cover on it. So one of the things that I like to do for putting covers in is make a dovetail joint. So we're going to put a sketch here. And we'll just draw this in quickly. So just to show you what I mean, a dovetail joint is like that. Okay? So that way if I cut a hole like that in here, then I can make a cover of this shape and slide it in. So how long do we need this back piece to be? That's going to be the board length plus our tab length plus the material thickness between them. Alright, so that makes that long enough. So in order to make that work, we need these to be a distance as well. So what we're going to do is we're going to make each of these dovetail lengths half a material thickness. Like that. So our other two ways we could do this is we could either set this distance over here as well, or we could set this distance to be just the board length and the tab length together. I'm going to go with the half the material thickness because it's a little more obvious as to what we're doing. Okay, so now where do we need that to go? We need it to be lined up with this edge here and also be centered in here. So the way we do that is we grab this one right here. This is our reference. We're going to reference this outside edge. And if I say that this piece, I better be careful. Before I do that, we better set a thickness here. Otherwise we're going to cause ourselves some trouble. So this, between these 2 points, is the material thickness. Alright, there. Now when we move this around, see if I hadn't set this distance, this piece could move past this one, but now if this piece moves, they all move together. Alright, so now we're going to say that this point and this point have a vertical constraint, so that puts us the right distance up this way. And now we need this to be a certain distance here, and that's going to be a material thickness again. You can see how we keep using material thickness as a reference, and that's why we set it, is so that we can continue to work with it all the time, and then if we change our material thickness for a different printer or something, then it will update all through the whole drawing. See, now we have a fully constrained sketch, and we're going to put this one also through all. Alright, so there are our 2 top openings. Alright, so next what we need to do is we need to make an opening here for the board, and an opening here for the tab. So we select the top, and we create a sketch. So we just need a box here, and a box here. Alright, so first thing we're going to do is we're going to say that these 2 here have a vertical constraint, that way they're at the same spot. And if we say that these 2 here are the same, then they line up over here. This one is going to be a board length. Okay. And then we need the material thickness space between these 2. And we'll put that measure on this side just for the fun of it. And then this one is going to be a tab length. Okay, so now we have 3 degrees of freedom. Why do we have 3 degrees of freedom? Well, we can move this in and out, and then we can place this in any place we want. Alright, so the width is obviously going to be the cell again. Alright, so now all we have to do now is place this somewhere in our drawing. Okay. So rather than using a reference point, what we're going to do is use the center axis again. And the way we set this up was that this is the outside edge, so then there's a material thickness, the opening, and then material thickness. So if we set the distance, the horizontal distance between there and there to a material thickness, now it's centered. Now all we need to do is center this, put this in the right spot vertically. And remember we made a dovetail, so if we use this, our opening wouldn't be in the right spot. Matter of fact, if I move up, you'll see that it's outside. We actually are going to end up with it here in between, because it's going to be centered underneath. I'm going to bring it up so we can see this point. And the distance between here and here is going to be the cell length divided by 2 plus material thickness. And there we go. Center it where it needs to be. Okay, fully constrained. Now, if we make a pocket and we set that to the cell diameter. You can see it goes in, but it's left us now a wall on the bottom of a material thickness. Okay? So the next thing we need to do is make a space here for our cell to fit into. That one should be pretty easy. We'll create a new sketch. We just need a box. And we're going to take off that constraint because it will interfere with this next one. So like I said before, we have this centered, so we'll just center that and say that this is the cell length. Nicely fits up. Okay, and then this is obviously the cell diameter. And now we need the spacing here, and we said, like I said before, again, here's our material thickness. Go. So now we're going to make a pocket. Now because this is only half the size now, this is the cell diameter divided by 2. Alright, there's a nice little hole in there. Okay, so the only things we have left now is we need to somehow make it so that the hinge fits in here, and we need our holes for our hinges. So if you look on my example I made, you can see that I have a hole here for the tab to fit in, but also have a hole down here for the wire, and I have the same thing here. And basically all I did is I created a sketch on this face and pushed it through on both ways. So that's what we're going to do again. So we'll come over to this face here and we'll create a sketch. And you notice we cannot see because it's in behind this. So I can just rotate this up. So we made a line. I'm actually allowing FreeCAD to create the horizontal constraints for me. There. Alright, so we didn't get some of our constraints. Let's make this vertical and make this horizontal. Alright, so just for fun, because we already have a tab length, we're just going to make this the same. Spreadsheet dot tab length is also going to be our width. Okay, so that gives us an 8mm hole to put our tab in. And let's make this wire hole here. We'll make it a material thickness, because that's a fairly large section. And let's take this one and this one and make them the same. So now we have a box sticking out the side. That is a square box here. That's a material thickness. Alright, so we have 3 degrees of freedom. 2 of those degrees are where we place this. The other one is the height. And because we're putting it in the box, we're going to make it the cell diameter again. Alright, so there's that. So how are we going to center this now? We didn't put our hinge centered. We used our hinge point over here. We didn't make the center of this centered. So again, we just do a little bit of math. We select that point and this edge point. So we know it's going to be, at least to the center, it's going to be the cell diameter /2. But then we have to take off the tab length /2. So that's the distance from the center to here of the whole thing. So from the edge of the box to that. But now we also need this offset, and that offset was a material thickness. So if we look at that, Now you see that this looks centered, and it should be. So the only degree of freedom now is centering this way. And because this is a cell diameter and height, and we have each this centered on that, if we make this distance here, the cell diameter divided by 2, that just touches the bottom, and there's our 2.4 material thickness on top. So there's our fully constrained piece. And we hit close. Alright, so now we need to make a hole. So we make a pocket. We're going to go 2 dimensions. So this first one here only has to go through that wall. So this one only needs to be the material thickness. Okay, so that's this side. Now you notice this one goes right through. Okay, so in order to get from this face to that face, we need the cell length. To go from that face through that first wall, we need the material thickness. And then to go through from that wall through where we're going to put the tab, we need the tab length. We hit OK, and now you can't see it, but if you look in here, you can see we have a nice space. Alright, there's all of those pieces. So the only piece left to do now is to make a space for our hinge here. Now this one gets a little tricky. Okay? So let's flip this around so we're looking at the front. Okay? In order to get this to work, instead of drawing on a face, we're going to create a new sketch. And we're going to use the XY plane. Okay? And hit OK. And what I'm going to do is I'm going to close this, and I'm going to hide this. We're going to go into our sketch. So we had it curved this way. So we need an opening going this way for where the other box is going to be. So we'll start with our arc like we did last time. And there's going to be a line going down like that. And our little curve at the bottom. And then to just, because we're just cutting a hole, we're going to make a line up like that. So this to there is vertical. And this is going to represent our outside edge. So first was the diameter of this that we set last time is the material thickness times 3, which is very small compared to what we were doing. And then we set the radius down here to the material thickness. Right. And now the length of this line, is half the cell diameter plus the material thickness. So we have spreadsheet dot cell diameter / 2 plus spreadsheet dot material thickness. Okay, like that. We're going to attach this to that, and we need a line to connect this shape together. There, there to there is 1, there to there is 1. This and this are tangent, and this and this are tangent. Okay, so we only have 1 degree of freedom, which is this distance here. So from the center of the hinge to that point is a material thickness. Like that. So this cutout should give us a cutout for the other hinge, the other door. There's a problem though. We don't have any gap in this. So what will happen is that when we print this, they will stick together. So in order to get the gap, first thing we need to do is we need to change this. This diameter, we have to add the gap to it. Like that. So that makes that slightly larger, which also means we need to move this a little smaller this way. Okay, so we're going to subtract the standard gap this way. And now we have a slightly bigger opening here that we're going to make. So we'll go back in and we will show this. You can see that this is going to cut out in here. Okay, now I do see a problem here. Why is my circle in here? My circle is in here because I did the wrong math here. That's the problem. So we're going to have to fix that math. Because this circle edge should be touching here. Otherwise we end up with our other hinge coming into our space. Okay, so we're going to leave that and go all the way back to our original sketch. You can see here that this spacing here is only 2.4, but this diameter is 7.2. Half of 7.2 is 3.6. So this should be at least 3.6 away, and it's not. Okay, so we need to move that away. So let's go back in here and we do spreadsheet dot material thickness times 1.5. There. That gives us a bigger thing, and you'll see here that this now is outside. Okay? Close, and all of these should get changed now. We'll just go down through, make sure they recalculate. Now if we look here, you see this is too big now, right? This is wider than our 2.4. So this one we did right. So this sketch here, no, that one's fine. Okay, so this ends up being too big, right? Because we only made this 2.4 from the center. This has to be times 1.5. And that moves it over here. That's better. And we'll go into this one and do the same thing. Same thing here. There. And everything nicely lines up. So now you can see that this is just inside there. We have a little bit more space. That's our gap. And we need to cut that space out. So again, we're going to use 2 dimensions, and this is going to be the cell length /2. Takes us right to the edge. And you can see that I have neglected to put it wide enough here, so we'll fix that. And we go here to cell length /2. Okay, so we obviously need this a little wider so we have more space. Okay, so we'll go back into our sketch. And we're going to go to this point here and hit delete, and that will delete the constraint. Now I can move this away. Right, and what we're going to do is add a line between these two, and we should make that line to be material thickness. There. So you can see we made it wider, make it close, and there we go. We have a nice spot there for our hinge cover to go in. Alright, not quite done yet. We need an opening here for our hinge to fit in. Alright, so we're going to create a sketch on this face. And we'll move it down so you can see, and you notice our nice little point there. Now we don't have to do any measuring from curves or anything because we got a nice point. And we need an opening. And its radius, its diameter, sorry, is the material thickness times 2. Alright, so there we have a nice round opening. Because that's its diameter, close, and we're going to give it a depth of also the same thing. And the reason we do that is because that is basically the square equivalent of a square hole, but because we did it here, I can fillet this. And if I add a fillet, you can see it starts to round out. We can do this at a material thickness, but because of the way FreeCAD works, this will not render as a fillet because they're exact. There's something to do with the way FreeCAD does math. But if I do a subtract 0.001 millimeters, it still shows up here, and it will actually show the fillet. And obviously I did that wrong. This depth has to be half that. This should only be a material thickness deep because we want it half of a circle. There. Now you can see that that is a half of a wall. And when we make our other one, we will add it in there. Now, again, because this is the opening, we should make it a little bit bigger so that it fits the socket. So we come in here, we're going to add plus the standard gap. And that will make it a slightly bigger hole. And you can see that has left a little space there, so we can actually add that in here as well. Alright, so that doesn't like it, so I'm going to take this part out and add it to the end. Still failing. Oh, I know why. Because we made the hole deeper, we also have to. We did it there. Do we make it wider as well? Or just make it deeper? Yeah, we didn't make it. We made it deeper, but not wider. Enough. Now we should be able to do the fillet. should have made this, because the way we're doing this, this should be standard gap times 2. There we go. Now we should be able to do that fillet properly. There we go. Nice semicircular hole. Alright. And we're going to do the same on this side. So select the face, create a sketch. Does it upside down, that's fine. And we'll remember what we learned on the last one. Spreadsheet dot material thickness times 2 plus spreadsheet dot standard gap times 2. Okay, okay, close. Make it a pocket. Set the pocket depth to material thickness plus the standard gap. Right? And we'll fillet that as well. What I should have done was do the other fillet first, but oh well. Material thickness plus standard gap minus 0.001 millimeters. There we go. There we go. There is our basic case. Should fit our cell nicely. And that's the first half done. Alright, so let's save our project in case anything crashes. Let's save this in my documents. Projects, 3D designs, and we're going to make this a 18650 Charger. Ooh. Spelled right. Charger case version 2. Okay. So there we've demonstrated making the case itself. Now we need, oh wait, we're not quite done. I forgot. We don't have our thumbnail here yet. So let's create a sketch. We'll create a nice little block. We're going to make the width of this hole the cell diameter divided by 4. And we're going to make the height of this the cell diameter, and we're going to take off this horizontal constraint and center this, and then we're going to set a vertical constraint here to there, and there we go. We'll hit close, make a hole, done. Alright, there is our case. Save it again. Alright, so that's the bottom. Now we need a top. So we're going to create a new body. We're going to rename it to top. And we need a sketch. And we should turn it the right way. And put it there on that plane. Now it gets really hard to draw because you have this in the way. So we'll close that for now. We're going to go to the bottom and change the visibility to false. Now we can go into our drawing. Alright, so you remember when we drew that, we drew it over on this side, so now we draw the cover on this side. And this is the center of our hinge, so we need our curve, our line, our ghetto fillet, line, another rounded edge, and because this is the box, ooh, that's not good. Let's get rid of these. Get rid of that. Go down here. Get rid of this line we drew. There. Alright. This one's going to come up to there. Now, if if you look on my example, you'll remember that the hinge has a rounded top. So we need to make sure we include that. So this rounded piece is going to come all the way down like so. And then we'll connect it to that, to that. Alright. So the diameter of this was the material thickness times 3. Okay. And we made these to be tangent. We made these to be tangent. And we made these to be equal. And we made the radius of these to be the material thickness. So, and then this and this have a vertical constraint. This and this is a vertical constraint. This and this is a horizontal constraint. This distance here is half the cell diameter. And then this distance here is the cell diameter. And then we had this gap to be 3.6, which is half of that, but also we could do the same thing by just selecting this point and this point and giving it a vertical constraint. And then we have a fully constrained diagram. Go back here and hit close. Now remember we centered this in the 650 cell place, so we can go 2 dimensions. And here we can go spreadsheet dot cell length minus the standard gap. So we can print this hinge case. Oh, cell length slash 2. And then we'll do the same thing down here. Cell length slash 2 minus the standard gap. Alright, so there is our cover. I haven't hollowed it out yet, but just for fun, let's bring this back and take a look what we have. See how they fit together? But if I zoom in, you can see there's a small gap there. If we look underneath, you can see there's a gap. Looking in here, there's a gap. You can just see. Okay, so we have a gap placed all the way around. And we'll hide that again, because we need to make a hole in the middle here. So we have a sketch. I'm just going to do a quick box. Take out that horizontal constraint. Center this here. This is going to be cell width or cell diameter. This is going to be cell length. So we only, yeah, that's right. So now we only have one constraint problem, and that's this. And so we can set that. Just very carefully grab that and that. And this was the material thickness times 1.5. There we go. Close. Make a pocket. We call this the cell diameter slash 2. We have a nice cover like that. Now we need our little closer for the thumb hole. sketch. Nice little box. And a box width is a material thickness. So. We're going to center this. And now the height of this, we did before, was the cell diameter, but now we have to subtract the standard gap. So it's not too wide. And then we want to set our horizontal distance from there to there is the cell diameter plus material thickness times 1.5. And that's centered nicely. Okay, there it is there. Now we're going to loft it. Now its height was the cell diameter slash 4, but also minus a standard gap. So otherwise it won't fit in. There we go. So all we have to do now is put our 2 pins on. So we'll start here. Create a sketch. Hinge pin is just a circle. And its diameter was 2 times the material thickness. Like that. We're going to save ourselves some time. We'll do a loft. That's 2 dimensions. This first one is material thickness. That one's right. This one here is going to be material thickness plus the cell length minus the standard gap. Because we made this smaller by a standard gap. Alright, so now we should be able to fillet this to material thickness minus 0.001 millimeters. And we should be able to add the other circle. There. Now we have 2 hinge pins. And so now we can bring this back. There we go. The only thing I forgot to do, so let's toggle the active body. I forgot to do a nice fillet on the outside edges, so let's fillet this to the material thickness minus 0.001 millimeters. Nice and round, and we'll do one over here. So we'll add that one. There we go. Nice and smooth and round. Pieces in place. So we'll print that and then we'll show you what it looks like. Oh wait, I should show you how to export that. We have these 2 pieces. You have to select both of them. That one, control that one. Now they're both selected. File, export. It's going to export as an STL. Let's bring up our Cura for my printer. Open up our file. Version 2. So there's our shape we just made. Now I have my printer set up with no supports. So it shouldn't have any supports. Right here, no supports generated. We'll slice and print it. 3 hours and 18 minutes. Well, I'll see you in a bit. Well, welcome back. I printed off our first edition of what we had designed, and you may notice that there's a couple errors. For instance, I forgot to put the hole in the end for the USB charger. I also forgot to put a hole or a mount in the bottom to hold the circuit board up halfway from the bottom. I didn't put any hole in here for the wires to come from the charger into the tabs. And then if you look closely here, you'll see that we have a space in this tab because these two are flush, and I don't know if you can see it on the video or not, but there's a little bit of a hold up here. So this cover is not quite coming down, and that's because we made this the exact same height as this. So they're half height, so I didn't put a space in there. What I should have done is made a space in here. As you can see, it opens quite well, closes quite well. So what we need to do now is lower this and this by a standard gap and bring this back up so that it matches up. Basically what we're doing is we're just lowering this side and this side. We'll do that in a sketch, and then we have to add a space here for the wires to come through for the two tabs, some support in here for the circuit board, and a hole in the end here for the USB. So let's get started. We have our sketch open here, and I've hidden the bottom, and here is the top. Now this part I've already done. I went in earlier today just to see if I could do it easily, and what I did is I went back to our original sketch here, and you can see what I did is I unhooked this piece from this line. I undid that constraint, and I added the standard gap here, and then I reduced this height by a standard gap. So if I go in here and show you, I've subtracted a standard gap there. So that lowers this down, but keeps this bottom and this the height. So all we've done is lowered that. And then in here, which is our top piece, I increase this height. So no longer does it have the standard gap. So this should be, because this is lower, this is also now lower by a standard gap. So we've just fixed that. So that's the easy part. There's our nice round ones. So the rest of the corrections we have to do are back on the other model. So what we're going to do is we'll go down here to View and set this to false, and go to here and set this to true, and we'll toggle the active body. So this one here is now the active body. So we need to do a couple of things. One of the things we need to do is add a hole in here for the wires to go through. So one easy way to do that is just to click on top, and we'll do a quick sketch on the top. Right here. Just a simple box. And we'll grab that line as our reference point. And we'll make it, let's make it a material thickness. That's a pretty good number to use. So we'll go spreadsheet.material thickness. Okay, so that's the right width. And we'll set these two to equal. Now, I haven't tried using the centering tool on this because the way it's designed is to center 2 points on a line. But there's an easy way to center this on this line. So the first thing we're going to do is we're going to make this and this a horizontal constraint so they're lined up, and you can see this is nicely the right width. What I'm going to do is change to construction lines, and I'm going to do a line from this corner. We'll fix that in a second. From that corner to that corner. Let's make sure that these are connected. Like that. Now, to make this centered, if I just set these two here to be equal, that will automatically center it. There we go. And so we'll make a pocket now. Now, the pocket for that is going to be the cell height because we've already taken off the other width. So, spreadsheet cell diameter Okay, and if we look, we can see that that is right at the same level as the rest of the bottom. So now we have a nice hole for the wires to come out. Now we need a slot so that, now we need a support for the charging circuit. So here's our charging circuit, and it's got this nice piece of foam on the top. So we'll use that to help hold it down. And it's got a clear area on either side here that we should be able to, yeah, that's weird. We should be able to put some supports in. So I'll put supports in from here and from here, but we'll only put them halfway, I guess. And that'll leave space for that to sit in. Let's just measure this board height. You'll notice I rely on my calipers quite a lot to do this. So, from the bottom of the board to the top of the foam is 13, roughly. Okay, so our cell height is 19, and that's 13. So we're going to make our little supports 6 high. We'll have to remember that. Actually, let's put that in the spreadsheet. We'll put our supports at 6 millimeters. And we'll make that board support height. Alright, so let's go back in here. Select that bottom face, create a sketch. We don't need construction lines right now. We'll just make 2 supports. And if we look at this board, they'll both sit in here and in here, and they can come in at least a material thickness, so we'll just use that. So we'll set this and this to the same and make it a material thickness. You can see I use that material thickness for a lot of things. It just makes it easy to adjust things. And we want these to be the same distance apart. We want these to be the same length. And we're going to make this half the board length. Spreadsheet dot board length /2. Okay, so that gets them the right distance there, and then we can measure the distance from this outside point to this outside point and make that a cell diameter. Now all we need to do is get them to sit in that corner. So we'll grab our handy dandy reference point. You can barely see that there's a point down in this corner. Click on it. See if I can click that and zoom in to get the point. And that point, we make them the same, and now we have a fully constrained sketch. Close. We'll loft that to a dimension of spreadsheet.board support height. There we go. So there's our board supports that the board should sit on. Now we need our USB port. So if you look on here, you can see that we're going to need a space at least 9 from that bottom. So we need a 9 high, and then there's one below it. So let's actually just take the whole thing, and it's 11, so let's make it 12 total, or actually let's do it in pieces because we're going to make 2 different references. So it's 9 high there, and 3 high the other way. Alright, so to get that, let's draw our sketch on the outside. Create a sketch. We're just going to use a nice box. width. It is spreadsheet dot USB width. And we're going to use our bottom edge as a reference point. And we can use the same trick for centering again. Make these equal. So now it's centered. Now for the height. We're going to make this height the board support height minus USB height. So that gives us a space on the bottom. And now for the height of the whole thing, let's do spreadsheet dot USB B height plus spreadsheet dot USB A height, and that gives us 12 and a half. So 12 and a half from bottom to top. Will that work? Let's see. Yeah, that'll definitely work. That'll give us enough space and space around for any other connectors. I'm gonna close, and we'll create a nice little hole. Oh, okay, and you see what's happened here? Does this look like the same? Let's take a look here. Spreadsheet dot material thickness, because I don't think this. Okay, okay. Let's go back into our sketch here for a second. So we had this height pretty small here, but if we look, oh, it's upside down. So we used the wrong reference height. That's going to make it not work. So we're going to go back into our sketch. We're going to change the reference. We're going to delete this, delete this, delete that. Leave all the other heights the same. And we'll choose this point as our reference. And add our centering lines. And we'll do our math over on this height instead. Spreadsheet dot board support height minus spreadsheet dot USB B height. There. Now we can close that, and it's lower there. So that should give us a pretty good opening where we can put our charger in. Alright, so we'll go back and look at our thing here, and you can see that it's a pretty tight hinge. There's a little bit of play in it. Other than that, I'm pretty happy with that design, so we'll print it again, and then when it's done, I'll show you how it actually comes off the board. It comes off the board like this, but it does have to be broken loose, so I'll show you how the next one gets broken out, and then we'll play with it. We'll put the circuit in and show you how it charges. Here's our print off of the printer. As you can see, it's pretty solid. But to break it loose, we'll just take a knife and we'll put a little pressure right there. You hear a little crack, a little pressure in here. Try to get a little crack. There we go. Just about there. And it looks like we got a little bit of touch maybe in here, or maybe back here. So just put our knife in and loosen it up a bit. There we go. And And we got a little bit of a seam here where it's touched, so we'll just run a knife along there. Take that little bit off. And you can see just like that, we have a print in place with a very little movement, opening and closing case. So the next thing to do will be to take this circuit board, and you can see that that just barely fits in here. Right, so we'll take these wires, and because of where they're at, I left that space there. I'm probably going to solder on new ones through the holes down the bottom. And these wires that are on it, you can see they're not going to be long enough, so we'll need some new wires. And we'll take some metal and fold it into our two springs. They're going to come out here and out here and be a little springy and hold the battery in when we go to charge it. But you can see a battery will fit in there nicely. Very little movement in it. So let's go find some metal. Alright, so we're looking for a different metal, and I wanted to find one that was flexible enough to be springy, but at the same time we could bend. So what I did, I looked all through all the different kinds of metal, and I found these tops for a can that seemed to be about the right thickness and springiness, and hopefully they won't corrode. And if we use my digital calipers here, we can see we have about 60 millimeters worth of flat space in diameter to work with. So let's jump into FreeCAD, and I'll show you another way that we can design something so we can figure out what we're going to cut out of these to make our metal pieces. Alright, so here we are back in FreeCAD. Here's our model that we had built and printed, and now we need to make a just a plan really of how we are going to cut that metal in order to have two pieces we can bend to make our tabs that are going to fit in here and fit in here. So if you remember, these are the height of a cell, and they are 8 millimeters wide, I believe. Let's look at our spreadsheet here. Tab length 8 millimeters. That's what we use there. So they're 8 millimeters wide. This little space is a material thickness, which is 2.4 millimeters. And we also made this 8 millimeters in through here and in through here, and then we have a material thickness as well. So these are both the material thickness plus 8 millimeters, which will take us to 10.4 for us. So what we need to do now is we need to go into, let's see if I can do it from Sheet Metal Designer. Okay, no. So I need to start with part design and create a new body. And we will create a sketch from the top plane. Alright, now before we get any further, I'm going to close that, and I'm going to go back to the model here, and I'm going to hide these so that we don't have to see them while we're working on our drawing. Alright, so we'll go back into our sketch. So if we start with the basics of our model, we're just going to do a square piece of metal. And I'm going to take out this one so I can center it like so. And this is going to be the base, so it's going to be pretty much the length of the space where we are holding it. So that's the tab length. So we're going to make this spreadsheet.tab length. Alright, so that is how deep it is. Like so. And then we need to make it wide enough. And I would like to be able to bend a piece of metal over top of the wire. So what I'm going to do is I'm going to make this spreadsheet.tab length plus spreadsheet.material thickness which gives us the one, the tab on the bottom, but then we're going to try and bend it up and around. So I'm just going to make it times 2. And that should give me enough that I can bend up and around. So there's our piece of metal. And it says we have 1 degree of freedom because we didn't constrain it this way. So let's just center it. This one, this one, this one, and center. There we go. Alright, and because we're dealing with very thin metal, the metal we have is extremely thin. So if I just measure it quickly with my calipers, it's yeah, 1/4 of a millimeter thick. So we're just going to make this 0.25. Alright. So there we have a very small piece of metal. Now how are we going to turn this into something? Alright, so let's go into the sheet metal designer, and I'm going to grab this edge and make a 90-degree bend. And see how I've made a nice 90-degree bend. So this will be the part inside, then we have a nice little bend, and then a vertical piece. Alright, so let's go into the properties for our bend. The bend is 90 degrees. The radius is 1 millimeter. I want it a lot smaller than that. So let's make it 0.5 millimeter. And then the length of it should be the same as the cell height. So if I do Spreadsheet dot cell diameter, there. So there's our tab going that way. Is that what we want? No, it's not. It's actually not what we want. So what we're going to do is we're going to go back to our sketch, and we're going to change this. We don't actually want to have the material thickness in there because we want to be able to bend it. So we'll take that out and hit OK, and hit OK, close that, and now you can see we have a nice square at the bottom, and this is the back part of our tab. Okay, and this is the inside piece. And since we made this radius 0.5 millimeter, we should change this length by 0.5 millimeter as well, just for consistency. So let's go back into our sketch, and we'll change that. And we'll say minus 0.5 millimeters. There. Okay, so let's just take a look now. If we go back to part design, one of our tools is this measuring tool. So let's measure from that point to that point. And you can see it gives me 2 different measurements. One is the straight angle over and down, and the other one is the angle. And what I want is this green one. So if I look at the green one, you can see it's 19.75 millimeters, which is 0.5 millimeter for our material thickness. But then we also have a little bit from the bend radius, so we need to change our length by 0.25. So I hit close, and we go back into our bend, and we change this, and we say minus, well, let's take off 0.5 millimeters because that's going to give us a little bit of extra working space, and then we can go back into these measurements and hit clear all dimensions, and now let's measure it again from that point to that point. Right, now we are at 19.25. We actually want it to be 19. We actually want it to be even a little less. So let's clear that again. And we'll go in here. And we're going to subtract off a full millimeter. Like that. Okay. So there's that bend. Now, I said I want it to be able to roll this up, so let's grab this face. Let's grab this face, and we're going to pad it out. And we're going to pad it out material thickness. And we're going to subtract off 1 meter. Because that will deal with our corners. So in here, we'll do the same thing. Go back to our sheet metal. And we'll make an angle. Change its dimensions here to the same thing. Spreadsheet dot material thickness minus 1 millimeter. Alright. That's looking pretty good. And let's make this 180 degrees. There. So that'll hold our wire when we solder it. Okay. And we should probably actually change this. Because we're going to put a second bend at the top, so let's subtract off another millimeter. And hit OK. Alright, now we're going to, we're still in sheet metal, so we're going to select this top edge and bend it 90 degrees. But this one is going to be spreadsheet dot tab length minus 2 millimeters. Okay, so that should fit in that hole nicely. Right, and then now we need an angle coming out to make a nice. So we're going to bend that one down, but we're going to change the angle to say, well, let's go 75. That. And we're going to change the length to spreadsheet dot cell diameter /2 minus 2 millimeters. Like that. And then we need one more bend. Make one more bend. And again, let's change this angle. Let's say about 45. Oops. I guess I should probably make it a little different. Let's make this a 35, which will give us a flat face. No, it won't. 25, I guess. There we go. That gives us a horizontal. Alright, so what we want to do is we want to change this angle a bit more. So let's go back to this one. And we'll make this down to 65. And we're going to make this a little smaller again. Minus, let's say 4 millimeters. So that's nice and shorter. And we'll change this bend and we'll increase the angle to 25. Gives us a flat area for it to push onto and be sort of flat, I guess. And we'll make the length 4 millimeters. Like so. And then we need just a little bit just to keep it from catching on the end. One more bend. And that one's going to be I think. Yeah, that looks about right. And that one's also going to be 4 millimeters. There. So if we build this, we should be able to put batteries in and out, and they should have good contact. Okay? So now what we want to do, alright, so I need a flat face. There we go. So there it is flattened. So here's my unfolded sketch. So now, if I change the visibility here to false, there is there's our unfolded object. Okay, so what we need is 2 of those, and one's going to be the mirror image of the other. But because we're doing thin metal, we can just rotate it. So let's do some measurements. So we go into part design and do some quick. So once we do it this way, from here to there, 48.8. So we may as well call that 49. So let's just reset it. We'll do from this one to this one. That one is 14.26. So how are we going to fit that on our circle? Let's close that. And we're in our unfolded sketch. Let's do a new sketch. On the XY plane. And we create a circle. We measured our clear space before. At 60 millimeters. So we can constrain our diameter 60. And we can set that and that to the same. And now, in order to fit these on, we have 14.26. So let's just quickly draw a shape that's similar. Alright, so this one is 14.26. Back to our part design. I have to close this. Go here. Clear all dimensions. Let's measure from here to here. 7.5. Okay. So this 7.5. Close that. Go back to our measuring tool and measure from this one to this one. 6.26. So this one is 6.26. And now all we need is this top thing here. So we'll close this, go back to our measurements from there to there. 48.9. Okay. This one is 48.9. Alright, so this will fit in there, which means that if this fits in, its opposite does. So that's what we'll have to do, is we'll have to cut the thing in half, and then we'll put one here and one there, and then we can fold that into our shape. So let's get cutting. Alright, here we are in my garage. We're going to try and get this to work. Let me turn this. See if we can get this to work. So you can see we have our plan here. Noisy kids in our neighborhood, as you can hear. Alright, so first thing we need to do is get a line down the middle of this. So I'm just going to guesstimate right about there. And there's a line down roughly the middle. Now, across the bottom is 14.25. And we need these to be mirror image, so if I put both angles the same, that would be 28.5. So let's find a spot where we can get 28.5 across. So we're going to measure here 14.25 or so. Right there. And then 28 over here. There's our bottom line. And they're 8 millimeters across the top. So if I measure here, I'm going to use the 1 centimeter as my center. And I'm going to measure over 8 right there. I'm going to measure 8 this way. Same thing down here. Measure 8 and 8. So we can draw a line across those. So it doesn't have to be perfect because this is just for our charging, and it's 50 this way, so let's hope we've got 50. And we do. We'll measure from the 1, which means we're going to go up to the 6. So, from 1 up to the 6, just there. There's our top line. Doesn't have to be perfectly square. I'll try. I can see that that's not quite though. There, that's better. A little closer to the square. 7.5 centimeters up. So 7.5 millimeters, I should say. So that's 7.5 there, and 7.5 there. Need to put our horizontals in there. So there you go to the center. 14.25. And draw that in. And 14.25 is right there. So there's our basic shape. We have to cut this out. This so they're roughly the same size. Alright, there we go. So we'll take that and we'll use the Dremel to cut it out. Alright, so we're set up with a Dremel cutting disc and we have our metal in the vise, so let's give her a cut. didn't work out. Yellow handles for straight. Let's see if that works. Well, that gets us into there. Alright, let's try this one. There. Alright, that's one. Take that off there. Alright, let's turn this. Let's see if we can get this a little closer to what we want. Well, that's closer. Let's take a little bit off this edge. I'll have to use a file on that after. Alright, so all we gotta do now is split this down the center. Which it doesn't seem to want to do. There we go. Just wants to bend. Alright, so we'll use the Gerber and break that apart. Hopefully. There we go. So there is our basic metal. So we'll take the file and we'll clean those edges up a bit. And hopefully that's springy enough. Well, hopefully this is not too blurry. It looks like I may have some condensation on my lens, but we made our little metal pieces to go in as our springs. You can see we can pull them out. Now I did end up making some modifications to it. I just had to use my little nippers from my 3D printer in order to cut them down to the right size. And we also planned for this little piece on the side to hold the wire. But I forgot with this end, that won't leave me an area for the wire to get by, and also it would get in the way of the two wires. I also 3D printed this slide-on cover. I just save you the pain of watching me design that, but as you can see, it lines up on both sides, slides in. It's all the same 0.2 millimeter gap. And we designed it with the slot in the center, but when we put our metal piece in, that will block that whole center thing, and we won't be able to get our wires through. So I just cut a V notch on either side. This one will be for the negative end and this side will be for the positive end. Because if we go back and look at our board, that's the side positive and negative are on. Now we're out here in my garage, which is why we ended up with some condensation on the lens because it's a bit cold and moist. But we're out here because that's where my soldering station is. So we're going to use this to desolder these two leads. And I'm going to use the wires off this JST connector because they should be the right length at least, and solder those on. And then we'll put them on the board and we'll give her a test after. Actually, I just realized that with it all closed up like that, I should be able to put this cell in here. So, if I put these cells in here, hopefully it's making good contact. I'll take this cover off. And I just happen to have a cable that we could use. So, if I plug this in, oh, it says it's charging. That's a good sign.